Hi, this is Dr. N. Sukumar, working as Professor in Department of Textile Technology in K.S.Rangasamy College of Technology, Tiruchenkood. In this video, let us see about the fabric manufacturing technology, the second part, particularly about the basics of weaving mechanism, about the weaving looms and the primary and secondary motions, which is weaving machine is technically termed as a loom. It is a device or a machine in which it is the interlacement of warp and weft yarn performed and thus the fabric is produced. If you consider that warp is one part of yarn which runs vertically and weft is another yarn, it runs horizontally, so that warp and weft interlace at each other so that the fabric is produced. If you see that by the mechanism of interlacement the fabric is produced. This for next, if you see that classification of loom, it is classified mainly into two categories. One is hand loom, another is power loom. The hand loom is divided into and further classified into five categories. One is vertical loom, next is pit loom and frame loom. This pit loom and frame looms are again sub-classified into two types. One is throw shuttle and another is fly shuttle. Next third type is Chitranjan loom and fifth type is Hattersley loom. These are the five different types of hand looms which are used globally. Next is in case of power looms, here the power of electricity is necessary for running the weaving machine. So again it is classified into three different categories. One is ordinary power loom, second is automatic power loom, third is modern power looms. In case of modern power looms, it is again classified into five different categories. One is projectile loom, next is jet looms. Jet looms are again classified into two different categories. One is by way of water and another is by way of air. And next mechanism is rapier mechanism and other type is multi-phase weaving machine. In this projectile, air jet, water jet and rapier, the mechanism of shedding changes, whereas in case of multi-phase we uses the shuttle for transferring the weft. If you see here this picture, we can see that it is a pit loom. As the name indicates that the weaver will sit inside the pit and the loom will be on the surface of the ground. So the movement of the heel shaft is done with the help of legs. And next is that the fly are by the throw shuttle. Next, it is an frame loom. Here the frame is used for the development of fabrics. If you see here, based on the size of the fabric what you want to shuttle, the shuttle will be inserted into the frames so that the fabric is converted. Next, it is Chitranjan loom. The name comes from Bengali. It is that semi-automatic loom which is made of iron and wood. Okay, this is the type normally we use over the local area or over the places. And the term called Chitranjan is from Bengali, so it is called as Chitranjan loom. Next is Hattersley loom. This is made full of iron. There is no wood part. It is fully made up of iron except the shuttle. Next, if you see the passage of warp and the cloth is formed through the loom. If you see over here, this part is a warp beam. Number one is a warp beam through which the warp threads are moved as a sheet form. This is a back rest. This part is a back rest, and next back rest plays an important role in increasing or decreasing the cloth cover factor. And next is that 4 and 5 are lees rods to divide the warp threads into two layers. Here it is normally the warp threads are denser in nature, so these lees rods are used to divide the warp threads. Again, actual dividing takes place here. It is called, this part is this part is called as heel shaft. This part is called as heel shaft. The heel shaft, minimum requirement of heel shaft for weaving a fabric is minimum of number of 2. By increasing the number of heel shaft, we can have a design effect in the fabric. So by that upper heel shaft and lower heel shaft, the warp threads are divided into 2 layers. Then the shed is formed. This part is called shed, so through which the shuttle is passed. And this part is called as a sleigh, and here we fix the number 8 called as reed. So this sleigh is fixed on a rocking shaft. It moves forward and backward to push the weft inside the frill of the cloth. The frill of the cloth is a part where the last pick is inserted. Then number 10 is that temple. The main work of the temple is after converting into a fabric, there may be a contraction of yarns due to crimp importing on the warp and weft yarn. To avoid the crimp, just we uses the temple. This temple pushes away, hold the breast beam. Then it comes over here. This part number 12 is emery roller, and or we can call it as take up roller. Then it is winded on the cloth beam. Here the final fabric is converted. This is the path of yarn, warp yarn and cloth through the types of weaving motions. The weaving motions are mainly classified into 3 different categories, 3 different motions. One is primary motion, another is secondary motion, third is tertiary, or we can call it as axillary motions. So any weaving machine, the weaving machine and axillary action is a part of that. It may be needed, it is not a compulsory part. So but the primary action is much more needed. If you see that what is mean by primary motion, as we say that it is a primary motion. So primary motion is a main motion of a weaving machine in textile industry. It is impossible to produce a woven fabric in any weaving machine or a weaving. That's why it is known as primary motion or primary mechanism. If you see that the types of primary motions, the primary motions are divided into 3 different types, 3 different categories. One is shedding motion, then picking motion, then beat up motion. These things, this complete one insertion of pick, one insertion of separation of warp, and one insertion of beating of converting into a fabric. I have put it over here a simple diagram, easy to understand. This is the first figure, indicates that the shedding mechanism, where the warp threads are divided into 2 layers. The top layer is called upper layer. The green thread is called as lower layer. So bottom layer. So in between this red thread and green thread, the shuttle is passed. That mechanism is, you can see it in figure number, second figure. If you see, the shuttle is traveling from one end to the other end. And next thing is that beat up mechanism, where the fabric is closed up with the inserted picks. Next, the shedding mechanism, what is meant by dividing the single layer of warp threads into two layer of warp. It is mainly divided to insert the weft inside the warp. Picking motion, or it can called as picking mechanism. It is nothing but inserting the weft yarn into the warp yarn. This mechanism, this is used to insert the weft. But the latest mechanism of modern looms uses rapier, projectile, and water jet and air jet are some of the mechanism which is used to insert the weft yarn into the warp sheet. Next, beat up motion or beat up mechanism, it is nothing but what is called as beat up mechanism. The last inserted pick on the fabric is called as fill of the cloth. Next is secondary motions. Secondary motions are nothing but let off and take up mechanism. Let off is nothing but causing unrolling of warp yarn from the warp beam. Next is take up mechanism is nothing but causing rolling of cloth rolled and cloth. Next is, if you see that what is in detail about let-off mechanism, this motion delivers the warp to the weaving area at a required rate and at a suitable constant tension, but unwinding it from the weaver's beam. Next, if you see the take-up motions, these motions withdraw the fabric from the weaving area at a constant rate that will give a required picking space, then wind it onto the roll. If you see that loom timing, it's a timing of different actions performed during one cycle of crankshaft, that is from 0 to 360 degrees. If you see, next is loom timing diagram. This is the loom timing diagram where we can see that the different timing mechanisms are necessary for performing the primary motions, that is shedding, picking and beat-up mechanisms. Then if you see that what is meant by axillary motions, the axillary motions are to increase the productivity and without affecting the quality of fabric. That is, main objective is that to have a higher productivity and reducing the fault which is occurring on the fabric. That is, to produce a good quality of cloth and to prevent damages, it is necessary to have some stop motions when the damages occurs on the weaving machines. If you see that there are 8 axillary motions. One is that warp stop motion, next is weft stop motion, warp protector motion, weft mixing motion, feeler motion, break motion, weft replacement motion, temple. These are the some of the axillary motions which is used on weaving machines. These are the motions are usually not absolutely essential. If you see that warp stop motion, main function is that when the warp is broken during the weaving action, the loom stops. That action is called as warp stop motion. Next is weft stop motion. When the weft yarn exists or there is a breakage of weft yarn, the loom has to be stopped. That indication is that weft stop motion. If you see that next is warp protector mechanism, it is that when the shuttle is laid in between the warp thread, the warp thread has to prevented the same way the shuttle has to be prevented. So for that we use as warp protector mechanism. Next, if you see that weft mixing motion, it is that mixing of different colors. In weft way, we have a possibility that increase the color so that there may be demand to produce a check effect on the fabric. If you see that next is feeler motion, this motion able to indicate whether the weft yarn is in the furnace almost to be up or not. Break motion, a mechanism to stop the weaving machine when the yarn breaks. It is much more necessary when there is some breakage occurs on the weaving machine. It has to be stopped. So that for that reason we uses two types of break system. One is shoe break and other thing is band break. Next is weft replacement mechanism. This is mechanism in which we uses that to replace the weft without stopping the hair. This is to maintain the width of the fabric. Thank you very much for your